We are here to tell you the story of a crazy idea, of how a group of undergraduates here at Davis decided to build the university's first satellite, despite having little experience in space hardware classes and very little funding. And of how, over the past couple years, that effort paved the way to the extensive research and development of industry-grade magnetorquers for UC Davis's first CubeSat mission.
Magnetorquers, also known as coils, are a component under the attitude determination and control system of our satellite. They will be used to stabilize our CubeSat, orientate our cameras to point towards Earth, and desaturate our reaction wheels. Coils are electromagnets and work much like a compass. When the coils and Earth's magnetic field are not aligned, they create a torque, or a twist, to align themselves. How much you can create that twist depends on the magnetic moment, expressed as M equals NIA, N being number of turns, I being current, and A being internal area.
Our first design were embedded coils, which are wires etched, milled, or printed onto a PCB. For etching, it took a very long time to prep and to develop the PCB, and to safely dispose of the chemicals. It was also tough to have repeatable, reliable results. Milling was much faster and more reliable, but we were limited to the number of turns we could include by the mill's tool size and by the amount of space on the PCB. During verification testing, the embedded coils only produced our desired magnetic moment when they exceeded our power constraints, which led them to generate excess, unwanted heat.
Our next design was to make 3 air cores, one for each axis, which is a wire that encloses an open area held together by a structure or space-rated adhesive. These types are low in mass and power consumption, but if we went with this design, we had to anticipate the time, material costs, and its complexity of integration. Torquer rods are a third type of coil, and they work much like the others. However, they consist of a ferromagnetic core that adds an extra boost of magnetic moment with the same number of turns and current. Research showed that 1 air core and 2 rods are widely used since it is compact and can be easily integrated. After hours of design and optimization, we created our final configuration.
We are currently assembling an autonomous coil winder for easy manufacturing and modifying our verification testing setup to be more reliable and repeatable. Despite our current global state, our team is still continuing to meet remotely to meet our mission deadlines.